Hello Year 11 and welcome here to the sixth video for our fourth topic. We're looking at frequency histograms and polygons. You've probably seen these before. We use it for graphing scores and frequencies, right? To look at perhaps trends or patterns in how often certain scores appear in our data set. Now, imagine that we have a data set with lots of different scores, none of them with very high frequencies. Our frequency histogram or polygon tends to be pretty flat, right? Because there's a whole lot of ones and zeros in terms of the frequency. And consequently, it's hard to see those patterns or trends that we're looking for. Equally, when we have continuous data, right? Remember like height or weight or something like that, then really, essentially, unless we're rounding it off, all of those scores really should be different, right? Continuous data, any two scores are probably at some point different. So there's a problem taking that sort of data and constructing, these quite useful frequency histograms. The way we get around it is we group the data, okay? We group it into class intervals, right? So instead of saying, people born on the 1st of January, the 2nd of January, and so on, right? If I wanted to have a look at trends of birthdays within our class, right? If I just looked at birthdays, maybe, in fact, probably, there would be two people in the room that share a birthday, right? That might occur, but all the rest are going to be frequencies of 1 and a whole lot of zeros in between, right? We're going to have about 300 scores, or 330 scores perhaps, or 340 scores that don't have, or possible scores that have a frequency of 0. Maybe we'll have a 2 somewhere. Right, but instead maybe I'll group it into January, February, March, April, and so on. So that then I'm grouping it by months. And I'm more likely to get some sort of useful data then. So, when we group it together, we call those class intervals. And for the purpose of doing some other stats on our data, it's helpful to have a class center. So we just find the center of that interval. Okay. Now, here we have some data, and we are going to, first of all, group this and tally it up, work out the frequencies, and let's do that. So here we go. I've got ages. Now, ages are a funny one. They tend to be discrete data because you go from being, 19 years old to 20 years old all in one go, not gradually through various in-between ages. Maybe you could say 19 and a half, 19 and 11 months or something, but no, that's not the way we tend to do it. So I'm going to call this discrete data. So the way we do this, I better put in my class centers. What's halfway between 0 and 9? 4.5, right? Add them together, divided by 2. 4.5, halfway between 10 and 19. I reckon that's 14.5, righto? And we're going to see here, I think, that we get 24.5, 34.5, and so on. Right, that's our class center. And to some extent, we are going to pretend that all of the scores in this group have this value. There are certainly problems when we do that, but we've got to do something. 74.5. There we go. That's our class centers. Now we need to tally these things up. So 37 goes into this group. There's a tally mark. Then a 12 goes up here, and a 19. And I know what you're thinking. You're thinking, Stan, well, this is going to take a very long time. But look, magic, filled in. There we go. Now we need to fill out this frequency column. And really, I just count up my tally marks. So that's an 8, a 7, a 6, an 8, a 5, 4, 3, and 1. Okay. It's a good idea to have a total here. And if I add these numbers up, I think we get 40. Oops. 42. A number not without its significance. So that's part A. Now to construct a frequency histogram for this data. Histogram is the column part. So we are going to need to have, what have we got here? 1, 2, 3, 4. We're going to need to have 8 columns. Right. My columns need to have a maximum height of 8 units. Right. Now here we have here, have a look. I think if we call this 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to go 2, 4, 6, and 8. And I should label this as frequency, because labeling your axes is important. Now, what we're going to do is I'm going to mark my class centers. You could put the interval 0 to 9, but frankly, it's less writing to write the centers. And I'm going to do it like this. My first one is going to go here, 4.5. And then here, 14.5. And so on. 10, it's all filled out. There we go. Now you can see my little bit of graph paper here is just a little bit too small, because I do need a gap at the beginning and the end. So the next thing I do is I have a look at that 4.5, right? That interval of 0 to 9, and it has a frequency of 8. So I go up to here. Whoops, missed a little bit. Now I've made these columns sort of 2 squares wide. That's because I need a half a column's width at the beginning. This is important. There's a half column width at the beginning. Righto. And by doubling up, by having them 2 wide, well, I can just leave a single unit there at the beginning. There's my first one. Now the second one, 7. All right, so that goes across here. Across. And down. Now you are using a pencil and a ruler, aren't you? Absolutely. Now you might want to pause it and finish it off before I do. But I'm going to keep going here for a little bit. There's my 6. And there we go. Right, look at that. There are all my columns, and I pretty much have my frequency histogram here. Now, another label here for my axis, and I'm going to call this age, I suppose. That'll probably do me. I'm just going to call this here, this thing here, we're going to call it age, and I should have something like a title at the very top. We'll call it Ages of Patients at a Medical Centre. Yeah, what an exciting name. Ages of Patients at a medical centre. Finally worked out why they call them patients. Right, you got to wait a long time. Anyway, there we go. That is a frequency histogram. It has columns, and this was for discrete data. Okay, discrete data. Now, if I had continuous data, it varies slightly. We still have a class center, but what typically happens, and sort of check the textbook for this, I suppose, is that instead of putting our class center here, what we might do is something like have a 0 here and a 10 here, and then a 20. And that way we can see that this column represents everything between 0 and 10 to 20, right? Whereas 10, well, in continuous data, we don't really have anything that's exactly 10. Okay, it would be ever so slightly one side or the other, so that's not such a problem. Whereas with discrete data, this would go from 0 to 9, and then from 10 to 19. And we go, what comes after 9 before 10? Well, in discrete data, nothing. Anyway, so ever so slightly different. Now, it's important to have this half column gap at the start and really for a little bit here at the end. If we had to draw a polygon here as well, the polygon simply goes to the top center of each column, right? Now, we go from the origin here and we join that one up, whoops, with a ruler. And then we do these things, right? And that forms our polygon. Now, you can actually have the polygon without the histogram. Right, so I should do this. Across, down, and to the end here again. Okay, so that's with the polygon. But this question didn't ask for the polygon, so I'm going to rub those out again because it's, well, oddly satisfying. Anyhow, so that is frequency histograms and polygons to some extent. Okay, hope you enjoyed. See you in class.